Okay, so last time we talked about how light is made of photons and how photons travel in rays or straight lines. And we talked about the difference of different types of material and how atoms getting excited and relaxing their photons emit their energy in the form of light or photons. So let's go ahead and do an example of a single ray of light, single photon, moving through the air, which then runs into some water. So what happens to this light ray is it bends, changes direction as it gets into the water. And when the light bends like this, because of the difference in the index of refraction, that bending is called refraction, where the light bends. Okay, so let's do an example to better understand this. Let's say that you are on a deserted island in the middle of the ocean and that you see a fish at about 45 degrees below the surface from your eye. So right here, this is theta 1. We'll say that theta 1 is 45 degrees. Well, as you can see from up here, because the reverse is also true, light coming from a source up to the water will bend out at the same angle that the light would come in, meaning that the fish is not actually here. This is what we call a virtual image. The real image, where the fish really is, would be about here, because the light from that fish moves up at a steeper angle before leaving the water at a different angle, before refracting and coming into your eye and fooling you into thinking that the fish is at a different spot. If you ever actually fish or try to throw spears at fish like a caveman would, then you will learn very quickly that you have to aim behind where you see the fish because of this refraction. So let's go ahead and do a full example of this and figure out what the actual angle of this light ray actually makes with the water. So to redraw the example in simpler terms, we've got a ray hitting a water interface. This angle here, 45. We want to know this angle here. So what we're going to do is use the first well-known law in optics, the study of light, called Snell's law. And Snell's law states that the index of refraction times the sine of the angle in that medium is equal to the index of refraction times the sine of the angle in the other medium. So here in 1 is 1, here in 2 is water, which is 1.33 index. So we actually have all the info we need in order to solve for this theta here, to solve for the refraction in the new material. To do that, first we need to divide both sides by n2, because we're solving for theta 2. Then we need to take the inverse sine of both sides to get rid of the sine, to solve for theta 2. So when you plug in 1 here, sine of 45 is commonly known as 0.7071. This index is 1.33. When you do the inverse sine of this, inverse sine is generally just something you look up in a table or look in a computer program. The angle in the water is 32.95 degrees, or a shallower angle. So using Snell's law, It's a very good, easy way to determine exactly what light will do when it goes through different materials. And it allows you to calculate all sorts of instances, and we're going to use Snell's law next time to calculate something even weirder than a fish not appearing where you think it is.